how to use PipeFlow Expert software to calculate flow rate through a gravity system. Through a gravity system, now the problem was the gravity feed system shown in figure 1.13 consists of a 16-inch pipe of 0.250 inch wall thickness, 3,000 feet long pipeline with a tank elevation at A equal to 500 feet and elevation at B equal to 150 feet. Calculate the flow rate through this gravity flow system using a Haxim-Williams C factor of 130. Now this is the figure. Now, having done this, what we did, if you use Haxim-Williams equation, the flow rate through the pipe will be 15,484 gallons per minute. Using Colobric's White equation, it will be 16,379 gallons per minute. So now let's make use of PipeFlow Expert to solve this particular problem. In order to solve this, first we now have to add a tank. Now the tank, let's assume the surface pressure is at atmospheric, and let's say it's of 2 feet. Then the bottom elevation, they said is 500 for A. So this is the first one, is 500 feet. Now, having entered those values, now I will just click enter. So as I click enter, the thing affects here. So now the next thing I will do is to select another point here, and now here the liquid level, I'll make it 2 feet. The bottom, I'll make it 150 feet, just like what was given, the elevation of the tank. I will just enter. So the value, the thing will be affected there. See, this is 150 feet. This is surface, that is the surface pressure. Then this is the 2 feet. This is 2 feet liquid level. Now the same also applicable to this. If you look at this thoroughly, you will also see is the same. So now we now need to add the pipes. Now we'll now select this pipe icon to add pipe. Select it. We'll now come here. Instead of to draw a straight line pipe from here to this point, I will choose to break it and draw a straight line pipe from here to this point. Now they said first pipe reminder, the default pipe value for drawing are this is. So now we need to change. So they say we make a change. You say yes. Now I will now select this material. Now for the material, I will leave it as steel, shadow faulty. Now I will leave it at this internal roughness. Now for the value of this, it should be 16-inch pipe. Now internal diameter of the 16-inch pipe, should be gotten from 16 minus 2 times the thickness of the pipe, which is 0.25, which is now, if you multiply 2 times 0.25, it will give you 0.5. 16 minus 0.5 will give you 15.5, which is our internal diameter. So now this should be 0.250. Now the outside diameter should be 16, because if a pipe from 14 inches up, let me just make a selection here. Let me now make a selection. No, this is not what I want. Let me go back. Let me go back to, I wanted to select this steel pipe. Now the reason why I want to come to this point is I've selected a steel pipe, schedule 40, 0. Now I will, instead of looking for the size here, you know, size 16, you have 15, you don't have size 16, is just one for that, and you don't have wall thickness of 0.25. so what I will do, I'll type it in here. I will say 16, the internal diameter is 15.5, just like what we have just explained. 0.250 as the thickness. It should be 16. See, from 14 inches down, the outer diameter should be 14 inches. When you look at it, it should be 14 inches. So now, this should be 16 inches. So now here, the weight, I will, since it's steel, for 16 inches, I will take this same value, because the weight does not have any effect on the result. So now we just say 82.860. now I will now save it to the save data to pipe. Now this data has been saved. Look at it, it's there. Now here, the length of the pipe we're using, since I've moved it from here to here, I will half it. So we are supposed to, the length of the pipe is supposed to be 3,000 feet. So now I'll make it 1,500. Meaning halving the pipe. So now just okay it. So here, from here to here is 1,500. Now join it to this node here. Then I'll right click to end the pipe, join. So now I will now select this, select there is item information to select item information. So now I will come here, select this node here. At this node, if you want to draw a line, a pipe, if you select a node, and from that node, as you draw the pipe to the next node will carry the elevation of that point. Now I want to change this elevation to 150. I will enter. So then now we are good to go. So that is all I needed to do. The reason why I had to break it is that so that we can know the speed, the flow rate at this node. So knowing the flow rate at this node means that we have known the flow rate through this pipe, because the next flow rate will be at this node, at the tank, this lower tank B. So now that was why I break it. If I draw it straight from here to this point, it will still give us the same result, but I needed to break it so that I can get the node at this, the flow rate at this node, which is the flow rate through the pipe. So now let's continue. Now click calculate. Now it shows us to say the net was solved with 2 warnings. The solution values are displayed on the drawing. Do you wish to view the detailed results table? Now say yes, I wish to view it. Let's view all. Now let's look at it. Let's look at the flow rate. The flow rate, okay, is in feet cube per second. So now, but we don't want our result to be in feet cube per second. Now I will just click redesign, go to units, now I will go to unit specify. I will look at the flow rate. I will change this flow rate to gallons per minute. Change the flow rate in USA to gallons per minute. Now I'll just say okay. I'll recalculate. Say yes. Go to all results. Now I'll go down to this. To all results. So what we got here is, look at what we got here. So at node, let me just open it up. And node at node 3 we have 16,184. we had 16,184. we have at this, look at this, 16, okay, no, at this node we have 16,000. okay, look at it, 16,000, the flow rate 16,184.72. the same here, so along the pipe. So now, so with this you can see that this is also very close to, what we got here. This is 16,379, what we got 16,184. so I'm done. Please subscribe to my channel and also hit the notification bell so that next time I create new videos, you can as well be the first to see it. Thank you.